Hi, Michelle. I'm going to finish up that last question since your computer died on you, and I'll send this to you in an email. So let me go back to what we were working on just to kind of finish up that problem. Okay, so we had put all the information in, and when it says find the linear model, anytime it talks about modeling and you have a data set, or if it has, if it uses the word regression, of course, or if it says, what's another thing, something about fitting, like the line that best fits or the curve that best fits the data, that's regression. Okay, so what we're going to do is we put the data in, and then we need to ask the calculator to take the information and make a linear equation out of it. So I'm going to go back to my main screen here. And now we're going to ask for the regression command. It also starts from the stats key, but it's a calculation. So we've already done the editing part where we put the data in. So we're going to go over to calculate, and then we have to select the type of regression that we want to do. They start with number 4. You can see the fourth one says Lin Reg. That's a linear one. Module 2 will look at quadratic regression, and we'll look at several others throughout the course. But we want to do number 4 this time. So I'm going to go down to number 4 for linear regression. Okay, this is just where it reminds us that it's using list 1 and list 2 for the XY defaults. And then I'm going to go down to calculate. It asks us in the homework to round to 3 decimal places, I believe. And this is going to show us the values. It says round to 3 decimal places as needed. So after it does the regression, it gives you the general form that the equation should have, and then it gives you the specific values for those coefficients A and B. So in this case, the slope is 2.9, because that's the value times X, and B, the y-intercept number, is 272.6. So neither one of these do we have to round to 3 decimal places because they are already only have 1 decimal place. So 2.9x plus 272.6. That's what we would put into my math lab. They're going to ask us to do some calculating with it. So I'm also going to copy those answers rounded to whatever it says into the first function slot here. Plus 272.6. Okay. You asked me earlier about the graphing of it. So let me clear this out. I'll put that in here a minute. We're going to look at the line and see how well the line fits the data. But this is how you would do the plots. Once you have the stats and you put the stuff in there, you put the data set in there. To see the graph, I started this and I realized somewhere in there you dropped out. So when you hit the Y equals button here, this will show you everything that the graph is going to show you, or the calculator is going to show you, but you also have to have the window set up correctly to see the area of the XY plane that holds the stuff you want to look at. So the calculators have a little quick zoom feature here for the data sets that you get through the statistical stuff. So it's a zoom, and all the way down here, number 9, that's what you're missing when you were trying to find the scatter plot. Put the data in, hit zoom 9, and we also have to tell it that we want it to graph the point. So they're still not going to show anything. So let me go back one more thing. So first, we need to tell it we want it to do the scatter plot. So that's what these are at the top. So when you go to Y equals, when you want to look at the scatter plot, if you had any functions in there, clear them out because you don't want to look at functions. You just want to look at the points from your table, and then go up and switch on plot 1. So just use your up arrow, and you can just use enter to turn them on and to turn them off. So I'm going to hit enter to turn it on. Now it's going to show me a scatter plot if I have any data showing up there in the stats. So now that I've told it I want to look at a scatter plot, now I'm going to go do the zoom and the zoom stat. I'm just going to hit the number 9. And that's how you see the points. Okay, so 2 things. The plot has to be turned on. So hit Y equals and make sure plot 1 is turned on. And then if you do a zoom number 9, it will readjust the window for you automatically. So if I hit the window settings, see how I didn't put those in myself. It looked at it from -10 to 110 for the X's, and the Y values go between 200 and something and 600 and something. And that's just because that's how we can get all the points on the screen. Okay, so you can look at it and see that's probably why they asked for linear model, because it doesn't look like it has very much curvature to it. So then we go through and we do the regression. So we do stat, go to calc, do number 4 for linear regression, have it do the calculation. This is our slope and our y-intercept. That's what we put into MyMathLab, 2.9x plus 272.6. I'm also going to put it here because we're going to use it to do some calculations in a minute. So 2.9x plus 272.6. Now, if I hit the graph, it should show a line kind of running through all those points. It's going to show us two things, the scatter plot and also this function graphed as a line. Okay, so when you look at that, that turns out to be the best line that we could come up with that lands close to all or most of the points. Okay, there are other lines that are close, but that's the best one. And it took a lot of statistical formulas that we don't want to mess with in that regression command to find that. Now, what we're going to do now is we're going to use the function that created that line, this y1 equals 2.9x plus 272.6. We're going to use this to make predictions or estimates about other points that, or other years that we don't know about, or they have an output. We want to know what year would correspond to that output. We can use that line, not the scatter plot. Okay, so if you go and you look at, that was part A, I think, was to put that function in. The next thing it asked on your test was to find f of 65. Okay, so f of 65 means I want to change the x to 65. Our calculators can do that in lots of different ways. If we're looking at the graph, if you're in the trace mode, the first thing when you've got a scatter plot is it's in the plot mode. But if you hit trace and then the down arrow, it will take you to that line, and then you can just scoot up and down the line and type in your own x value. Like if I'm just trying to estimate it, I'm watching my x values and kind of scooting over, and it gets close somewhere in here. There it's close to 65 in here somewhere. I want it more accurate than that. So while I'm in the trace mode, I just type in the x value I'm trying to look for, which is 65. So trace 65 and then hit enter, and it will give me that answer right there, 461.1. That's the estimate of the population in millions for, what would that be, the year 2065. Okay, and I know we don't have that on our table. It skips from 2060 to 2070. So we have 60 and 70 in our table, but not 65. So that's the estimate for 461.1. That would be the population in millions for the year 2065. That's the projection for that. If for some reason your window isn't set up to where that x value is showing, here's another thing you can do real easy, just from the main screen. You can use function notation. Like in the homework, it says find f of 65 in the parentheses. We just type, instead of f, we type y1 because that's where we typed it. Let me show you where the y1 is. The green F4, that's how you get your names of your functions. So alpha F4, select y1. That's like your f of 65. We're just using y1. Then we just use our parentheses like that. And see, there's the same answer, 461.1. That way of using the function notation doesn't depend on your window settings up in a certain way or anything. So that's a couple of ways you can plug the 65 in. Of course, you can always just do it manually like this. Plus 22.6. If you don't want to use the function notation at all, you can do that. I'm just trying to save you some time. So that's the answer to part B, where it says, what's the population projection for the year 2065? Actually, it doesn't say that. It says find f of 65. That's the number. And it also asks you to interpret that. So that means in the year 2065, the population is projected to be 461.1 million people. I think it's just a drop-down menu of choices, and you choose the one that says 65 is for the year 2065. The answer, 461.1, is the population. All right, and then the very last one it asks is, in what year is the population going to hit? Is that right? Let me go back and look at it. Oh, no, it asks us another question with a different year. It says, what does this model predict the population to be in 2080? So 2080, according to the model, not the data set. We can look in the data set, and it says in the data set, I'm looking at it right here, it says 498.8. But let's see what the model actually does. So let's go back here. I'll stop it. So I'm going to do the same thing, just plug in 80 there. Third in a second. Calc. Y1 is what I call the function. I'm going to put in 80. 504.6. So the model predicts the population will be 504.6 million people in the year 2080. And it's a little bit higher than what it says in the table, but it's in the same ballpark. The table, I'm going over here and looking at the table. The table shows for 2080, 498.8, so just under 500. And then when we did the calculation, it comes out to 504.6, just over 500, so it's about the same. So I think that's the last question it asks is just, is it close? All right, so hopefully that's enough to answer your questions a little bit. Let me make sure there was no other question there. Yeah, so it asks you to do 50, when you answered 518.5. You had a little bit different function when you were doing yours. So to get to the scatter plot, you have to turn on the scatter plot and then you do a zoom 9, and that will show you your points. And then to get that line for regression, you have to get a stat over to calc and then select number 4, go down to calculate, and that will give you your slope and your y-intercept, and you put that together to form the answer that's the function, and then you use that function to answer the other questions about input and output. All right, let me stop this so I can get it sent to you, and hopefully good luck on your test. I'm sure you'll do much better this next time.